Welcome to LECO Academy. So in this video we're going to handle a question that came in 2023 under electricity. So we're going to handle question C2, and the statement says table C 2.1 shows data collected from an experiment to determine the resistance of a conductor. So this is the table here. On top here it shows the voltage, and down here it shows the current, which is measured in amps, and the voltage, that is volts. So the first question they're saying, plot a graph of a voltage against current. So when plotting the graph, what starts, like here for this statement they're saying voltage, so what starts is going to be on the y-axis. So voltage against current, this current, it will be on the x-axis. Now if we check the range for the voltage, this is 0, 4, 10, 16, 26, 42, and 80. So from 0 to 80. And the range for the current, that is 0 to 12. So the scale for the voltage, if we get our graph, we are going to use 2 centimeters. So this box here, one box represents 2 centimeters. So this 2 centimeter, we are going to use 10 units. So 2 centimeters to represent 10 units on the voltage scale. So here we are going to write a 0. So we draw a vertical line representing the voltage. So for the vertical line, which is the voltage, 2 centimeters to represent 10 units. So if we are using 2 centimeters to represent 10 units, if this is a 0, here we're going to write a 10. So here it's a 10, 20, 30. So the units, they will increase by 10. This is 40, 50, 60. So this is 60, 70, and this is 80. So this scale here, it is representing V. So V meaning voltage, and on the x-axis we have current. So current, if we check the scale that we have here, the range, so the range that has been given 0, 2, 4, 6, 8, 10, 12. So from 0 to 12. So for our graph, we are going to use 2 centimeters to represent 2 units. So from this point to that point, here it will be 2. So this is 2, and this is 4. This will be 6. Eight. So we are increasing by 2. And the last figure, that is 12. So this scale here, the x-axis, this is representing the current, which is measured in amps. And here we said voltage, which is being represented by V. So V, this is volts. So we can write voltage here. So after putting the numbers, the figures, we can now come up with the coordinates. So here the coordinates that starts, we have 0, 0. So 0, 0 already it is at this point. I'll use a star. So that is 0, 0. The next column we have 4, 2. So 4 is for voltage and 2 that is for current. So current we have 2. So this is a 2. Now voltage we said 4. Now if here we are using 2 cm to represent 10 units, meaning starting from 0, this is 1, 2, 3, 4. So 4 will be here. Now this is 4, 2. So on our current, 2 is here. So we are going to count 4 lines. 1, 2, 3, 4. So our point will be here. This is 4, 2. The other point, and this is 10, 4. So 10, 4 on our graph. So 10 is here. This is 10, and this is 4. Where they meet, that's where we put the point. We also have 16, 6. So 16, 6. This is 6. So 16 is after 10. So this is the line for 10. So 10, this is 10, 11, 12, 13, 14, 15, 16. So 16 is here. We put a point. This is where they meet. The other point, 26, 8. So 26, 8. 8 is here. So this is the line for 8. And 26. So this is 20. This is the line for 20. Okay, so 8. This is 8. Here this is 20. We count 6 lines. We count 6 lines. So this will be 21, 22, 23, 24, 25, 26. Our point is here. The next column we have 42, 10. So our 40 is here and 10 it is here. So we are going to move with this line. So the line for 40 it is here. So we are going to count 2 lines to make 42. So this is 41, 42. The next we have 80, 12. So 8, 12. So 12 is here. We are going to follow the same line, this line for 12, and 80 is our last figure. So 80 it is here. This is 80. So after coming up with the coordinates, we then join the coordinates to make a curve or a graph. So when joining the points, you use a freehand. Okay, so this is how our curve looks like. Now that we are done plotting the graph, so question B, they're saying use the graph to estimate the resistance when the current is 5 amps. Now the formula that we can apply here, it is for the current, so number B. This is number B. So we know that current is equal to voltage over resistance. So to make resistance the subject of the formula, E over 1, we cross multiply. So this will be IR is equal to V. Then we divide both sides by current. Resistance therefore will be equal to voltage over current. So this becomes the formula for the resistance. Now, the data that has been given, current that is 5 amps. So for the voltage, we get it on the graph. So if we check the graph, so down here, the scale which is down here, it is representing the current. Okay, so if we've been given the current to be 5 amps, and if we check the scale down here, this is 2, 4, 6, so 5 must be in between 4 and 6. So 5, we are going to count the lines. So these lines here, they are 10. So the line that is on the middle, it makes 5. So 1, 2, 3, 4, 5. So this is a 5 here. So this is a 5. So where it is touching the curve, that's where we are going to get our voltage. So it is touching the curve at this point. We draw a dotted line. Okay. So if this is 10, 11, 12, 13. So our voltage, that is 13, if we get it from the graph. Voltage is equal to 13 volts. Resistance therefore is equal to, so voltage, that is 13, divided by our current, that is 5. Okay, so 13 divided by 5, it is giving us 2.6. So 2.6 is our resistance. 2.6 ohms. That's the SI unit for the resistance. Now for question C. So C, we have two questions, C1 and C2. So question C1, they're saying, does the conductor obey Ohm's law? So if we check our graph here to answer question C1, this graph here, it is curving. So when a graph is curving, it means that the conductor does not obey Ohm's law. So the graph must be in a linear form. So for number C1, it does not obey. C2, they are saying, justify your answer in C1. So since in C1 we are saying it does not obey, the reason is because, so for number C2, because, so this is the reason here, because the curve is showing in nonlinear form. So for a conductor to obey Ohm's law, its graph must be straight without curving. The graph that we have, it is curving. So when it is curving, it does not obey Ohm's law. When it is in a linear form, it obeys Ohm's law. So question D, they are saying, what term is used to describe such type of a conductor? So a conductor that does not obey Ohm's law, so number D, we call it a a non-ohmic conductor. So a non-ohmic conductor, a conductor that does not obey Ohm's law, we call it a non-ohmic conductor. Now question E. Give an example of a conductor that behaves like this. So a conductor that behaves like this is a filament bulb. So this is how we handle questions under electricity when given a graph.